Hello, good morning, everyone. It's 11, so it's time to start the webinar. My name is Fabio Tombolato, and today with me, there will be Hendrik Jansen. Hendrik is a member of our product development team and is responsible for our laboratory in Luxembourg. And he will be the moderator of the speech. Please, Hendrik, the stage is yours.
Yes, hello, everyone. Welcome to today's webinar. Graphene nanotubes add conductivity with better processing to polyurethane rollers and sleeves. My name is Hendrik Jansen. I'm technical engineer at the company OCSiAl, and will guide you through the more organizational part of the webinar. The webinar will consist of two parts. We will start with the presentation of Fabio and then followed with the question and answer sessions afterwards. When you look at the bottom of your screen, you will see a Q&A icon. If you click on it, the text box will open and you will be able to ask your questions live during the webinar itself. I will start answering some of the questions immediately, and some we will keep for the end to discuss with Fabio more in detail. In case you have some specific, more confidential questions regarding your specific project or your formulation, please send the mail to webinar@oxial.com, and we will contact you to discuss your specific project in more detail. And finally, of course, the slides of the presentation will be sent to you in the coming 1 or 2 days. I'm happy to present our speaker, Dr. Fabio Tombolato. He's the technical support manager for the EMEA region at OCSiAl and has a large background in the polymer industry. He has a PhD degree from the University of Padova in molecular science with a strong focus on soft condensed matter and polymers, and is working now for more than 14 years in different fields of the polymer industry. He worked on developing new coatings in civil, industrial, or textile applications. He worked on adhesives, on emulsion polymerization, but also on the development of new composite technologies for printing applications. And today he will present to us how you can use graphene nanotubes inside of your formulation to once get electrical properties and so enhance the processing of the polyurethane rollers and sleeves. So Fabio, stage is yours.
Thank you, Hendrik, for this very kind introduction. I think it's time to go straight to the topic of the webinar. And today it is a very pleasure for us to share with you our experience on how graphene nanotubes can be used to introduce the conductivity in rollers and sleeves without affecting the production process and without compromising all the other properties of the materials that are important too. This is the scheme, the summary of the webinar. I will give you a brief introduction of what graphene nanotubes are and which kind of properties they can bring to the material. And then we will focus on application in rollers and sleeves, and I will show you some industrial applications. Graphene nanotubes, they are also called single-wall carbon nanotubes. They are namely made by a single sheet of graphene that is rolled up to form very long and very flexible tubes. Together, the flexibility, together with a very high aspect ratio, together with a wall thickness of only 1 atom, give to this material very peculiar properties. Sorry, there is an issue with, okay. Graphene nanotubes are known to be excellent electrical conductor. They have extraordinary mechanical properties. Just to give you an idea, the tensile strength of this material lie in the range of terapascal. And thanks to the 3D network that they can create inside the polymer, there will be conductivity to your material. In this cube, you see the typical 3D network generated by only 0.1% of graphene nanotube. Just to give you an idea, to have a similar 3D network with the standard conductive additives like carbon black, you should add more than 100 times more material. And now let's focus on roller and sleeves. And this slide, you see a typical sketch of a roller on the right, namely made by a thick layer of thermoset material, typically polyurethane, wrapped on a metal core cylinder. And the sketch of a typical sleeve on the left, made by 3 different layers, the base layer and the build-up layer and outer layer. The structure of sleeve is very complicated, very complex, can be done using different material. They can be pure polymer or even composites. Graphene nanotubes are so versatile that can be used to bring conductivity independently of the material and independently of the complexity of the structure. There are different additives that can be used to bring electrical properties on thermoset material with a focus on polyurethane. Carbon black and chopped carbon fiber are well-known additives that are used to bring conductivity in the full range, antistatic to conductive, and the conductivity that they will bring will be stable over time. But they bring some drawbacks. Thanks to the high dosage needed to achieve the conductivity, they will have negative influence on the rheology properties and on the mechanical properties of the material. And for sure, it is very difficult or namely impossible to develop color products. Alternative materials that can be used are liquid antistatic agents. They are liquid, so they have limited influence on the rheology, and it is possible to develop color products. But they are very limited in the range of conductivity. So basically, only antistatic products are possible. And furthermore, the conductivity that liquid antistatic agent will bring is strongly affected by the humidity of the ambient. Graphene nanotubes are the only additives that can bring benefits to all these parameters without any kind of compromise. With graphene nanotubes, you can achieve the full range of conductivity from antistatic to conductive. Conductivity will be stable over time and independent of the condition. And thanks to the high vary efficiency, we are saying that starting from 0.02, 0.03%, you can achieve the electrical properties. Graphene nanotubes will have a very limited influence on the rheology of your material, and they will not affect negatively, or even they will improve the mechanical properties of the material. And again, thanks to the very low working dosage, it is possible to develop color product. And I will show you later in the presentation. In this slide, we have summarized the most important key benefits that you can achieve using nanotubes in the production of rollers and sleeves. As I told you, graphene nanotubes, thanks to the 3D network that they will create inside the material, they will bring a permanent electrical conductivity that will be homogeneous not only on the surface, but also through thickness. Graphene nanotubes are namely inert from a chemical point of view, so they will not affect in a negative way the casting process, and they will not affect the curing process. This will let the possibility to achieve the full range in terms of the material, and they will not have any effect, negative effect on the quality of your products. Furthermore, it is possible to develop also colored products. The unique morphology that nanotubes will create inside the material will add the possibility to create this 3D conductive network, and the conductivity will be stable over time. Furthermore, it will be stable against a typical effect that is happening on the roller, on a polyurethane roller, abrasion on the surface. Nanotubes will create conductivity not only on the surface, but in the bulk of the material. In this slide, you can see a typical issue associated with the use of standard conductive additive like chopped carbon fiber. The issue is related to a non-uniform conductivity that you have inside the material due to non-uniform distribution of carbon fibers inside the material. On the right, you see the picture taken at microscope of a thermoset material enriched with a dosage between 4 and 6% of chopped carbon fiber. As you can see, they are not even distributed on the both sides of the composite material. The net effect is a different level of surface resistivity, one side to the other, and a negative effect on the conductivity through thickness. The same system you can see on the left, enriched with only 0.02, 0.03% of TUBALL graphene nanotubes. And as you can see, it was possible to achieve a surface conductivity which is uniform one side to the other in the range 10.5 ohm per square. And the net effect was homogeneous conductivity also through thickness in the same range, 10.5 ohm per centimeter. As I told you, graphene nanotubes are namely inert from a chemical point of view, so they will not affect the curing process. And it is possible to achieve the full range in terms of short A for your composite material, for your thermoset material. Furthermore, thanks to the very low working dosage, they will not have negative effect on the casting process of your material. As I told you, one important property that you can achieve using graphene nanotubes is color. In this slide, you see the typical percolation curve of graphene nanotubes. As you can see from the graph, starting from a dosage between 0.02 and 0.04% of graphene nanotubes, it is possible to achieve a volume resistivity in the range 10 to 4, 10 to 6 ohm per centimeter. And at this dosage, it is possible to develop colored products. And now let's focus on some industrial cases. But before going to the topic, I want to share with you our portfolio that we have developed for thermoset polyurethane, because it helped me to introduce an important topic, speaking with graphene nanotubes. As I told you, graphene nanotubes will bring electrical properties to your material thanks to the 3D network that they will create inside the material. So dispersion plays a crucial role. We, as OCSiAl, took a lot of effort to develop graphene nanotubes concentrates, we call them TUBALL matrix, that help the customer to have a very good dispersion using the standard equipment. Concentrate matrix are made by graphene nanotubes and the carrier. The carrier is specifically designed according to the target system that they need to be used in. We have grades specific for hot cast polyurethane. We have grades specific for polyurethane, solvent-based and solvent-free. And it is not the topic of the webinar, but just to share with you that we have also grade specific for polyurethane water-based, 1 component and 2 components. The first industrial application that I want to share with you is polyurethane rollers for industrial application. In this specific case, the target was a surface resistivity below 10.9 ohm per square, and this target was achieved using only 0.2% of TUBALL matrix 202. TUBALL matrix 202 is a 10% concentrate of graphene nanotubes in a specific carrier for polyurethane system, and it was possible to achieve the electrical target without affecting all the other properties of the material. Another application coming from the printing world, roller. This specific request was for a surface resistivity below 10 to the power of 6 ohm per square. And the target was achieved with only 0.4% of TUBALL matrix 200 series. 200 series is a specific series that we have developed, and they can be used for polyurethane, but they also can be used for epoxy system. This case is very interesting because it shows you how graphene nanotubes can also improve the quality in your production. In this specific case, 17% of conductive carbon black was substituted only with only 0.4% of TUBALL matrix. It means that using TUBALL matrix, you will have less material to move in production, you will not have dust production, and you can guarantee a clean production site. Another application, different from roller and sleeves, but it makes sense to mention here. Diagnostic disc for a gas and oil application. The target was volume resistivity below 10.9 ohm per centimeter, and the target was achieved using a dosage of 0.3% of TUBALL matrix 202. Again, this conductivity was independent of the condition, and the dosage of nanotubes did not affect negatively the mechanical properties of the pure polyurethane system. Before concluding, let me share with you an overview of the current application, the most intriguing one, of nanotubes. It has been estimated that more than 50% of all material could be enhanced using graphene nanotubes. Graphene nanotubes are now used in the batteries. They will play a crucial role in the EV transition, and they are used in the batteries to increase the energy density storage. Graphene nanotubes are also used in tires, not only to bring electrical properties, but to improve the mechanical properties of the tire. If you want to have more information about 2 topics, batteries and tire application, you can come in contact with us. We have a dedicated team that are working on these 2 important topics. Graphene nanotubes are also used in rubber and silicones. Just for you to know, they are used in high very conductive silicones for wearable device. They can be used in thermoplastic and composite. We spoke about that. And they also can be used in coating. One interesting application is, for example, in car seats coating, where they are bringing not only anti-static properties, but also anti-dust effect, which is very important for this kind of application. Sustainability is a very important topic when developing a new product. And doing better with less is a clear statement that fits with the use of graphene nanotubes. Thanks to the very high efficiency, a low working dosage is needed to achieve the electrical properties, and this will strongly contribute to the reduction of the CO2 emission associated to the production process. Furthermore, graphene nanotubes will extend the durability of your products. A typical question that we receive from people or new customers that are not familiar with nanotubes is, are these materials available at industrial scale? Are they available authorized in Europe? Graphene nanotubes, TUBALL graphene nanotubes, are the only single-wall carbon nanotubes that completed the registration to the REACH, and they are allowed to commercialization up to 100 tons per year. They are also available in the US market. They are EPA compliant without any kind of limitation in terms of volumes. Few words about OCSiAl. OCSiAl is a global leader in the production of graphene nanotubes with only scalable technology that make this material available at industrial scale. We are not a global leader in production, but we are also, our mission is to bring the scientific knowledge and the technological industrial application of graphene nanotubes to the forefront. We are present in more than 50 countries with the production site, R&D centers, technical centers, sales offices, and distributors. We are a team of more than 550 people, and what I'm proud to share with you is that with a team of more than 100 people in R&D and technical departments, we can support our customer in each phase of their project, since the very beginning R&D activities up to the industrialization phase. We are now to the conclusion of the webinar. I hope that I will raise your interest in graphene nanotubes. If you want to know more about this material, you can find a lot of information in our website, tuball.com, or I suggest you to also to visit our YouTube channel, where you can see different applications of nanotubes. You can see guidelines, you can see how to manage them in the laboratory and how to move in the production. For any kind of question, you can also write an email at webinar@occsial.com. Thank you very much for your attention, and I think now we have quite some time for a question and answer.
Thank you, Fabio, for the very interesting presentation. We do have some questions. I think I will start with one is, what support do you specifically provide during the testing or the processing of the nanotubes for your customers?
Yes, we can support our customer at different level. Usually what we can do is to do like a preliminary technical meeting, face-to-face or online, where we share with our customer how to choose the right grade, how to set up the laboratory test. Then we can support them. We have a laboratory in Luxembourg, so we can do some study for them. We can do some preliminary study for them. And also we can cross-check the properties of the material. For example, the conductivity. We are fully equipped to check all the properties of the material in our laboratory. Then we can, with our technical team, we can support the customer in field, so we can do a lab test with them at their laboratories, and also we can support them in the industrialization phase.
Maybe two questions which I can couple. So one is, who does distribute our nanotubes in Italy? And the second one was from the same person. This is why. You talked a lot about surface resistivity, but how does the conductivity go in volume?
Okay, for the, let's say our distributor for the Italian market is Reschem, so you can come in contact with them to have all the information to receive samples of graphene nanotubes, our matrix concentrate. Yes, I talk about the surface, but as I told you, graphene nanotubes will bring a uniform 3D network, conductive 3D network in the bulk material. So you will have both surface conductivity and bulk conductivity, conductivity through thickness that will be stable over time and totally independent of the condition like humidity.
One more question is, how does it affect color, like specifically wet color components?
It depends. I mean, as I told you, it depends on the level of conductivity that you want to achieve. And according to the level of conductivity you want to achieve, you need to add a specific dosage of graphene nanotubes. It depends also on the material. Let's say that starting from 0.01 and 0.02, you can also achieve the electrical properties being between antistatic and conductive range. And at this low dosage, it is possible to also develop color like red color.
Next question is like how to get the data sheets, technical SDS on your website. I guess it's on TUBALL.com, huh?
Yes, you can find all the documentation in our website. We have a TDS, we have MSDS, and also if you come in contact with us, we can share with the customer additional technical information that are very useful, like processing guidelines. So you have all the details how to process nanotubes in the lab for the test and also in production. And you can also have some optimization guidelines for specific formulation. So you have like a base line formulation with all the suggestions from our side, how to choose the right ingredient and the right component to optimize the conductivity.
One question is, we improved the conductivity or the electrical conductivity a lot. Are there some mechanical properties which we improve, or how does it compare with other conductive additives like abrasion resistance, for example?
What we see from our experience is that at this very low working dosage, 0.01, 0.02, the mechanical properties of the neat material are preserved, compared, for example, to all the other conductive additives like carbon black or a liquid ionic system that use to have negative effects on the mechanical properties of the neat compared to the neat material. Then for sure, in some cases, graphene nanotubes can improve the mechanical properties. In some cases, we saw an improvement in the mechanical properties, but it's strongly dependent on the dosage that you will put in your system.
And I think here's also an interesting and important question is, what speed do you use for the dispersion of your nanotubes inside of high viscous products like polyurethane systems, for example?
This is an information that we share in our processing guideline. The customer can find in the processing guideline. We suggest to work for the dispersion of our TUBALL matrix, 10% or 5% concentrate. We suggest to work at a shear rate at 10 meters per second. Ideally, the range is between 7.5 and 15 meters per second. We suggest to work at 10 meters per second to achieve a good dispersion. And another trick that we suggest is to work in two-step mixing. So like to do a concentrate of our TUBALL matrix, typically at 2%, and then do a second step of dilution to the target dosage to achieve the target conductivity level that is needed according to the project.
One more general question, but I think it's important as well, is could you share the resistivity range, antistatic, conductive, and also what's the base color of the nanotubes itself?
Okay, we consider antistatic between 10.6 and 10.9 ohm per centimeter or per square, and we consider, let's say, conductive between 10.4 and 10.6. This is the typical request that we have from our customer. And the typical, I mean, the base color of our matrix, you will see they are like thick paste and they are black.
And then I see there's one more question, but I think it's more into the thermoplastic applications. Which grade is do you have a grade which is suitable for polypropylene systems?
Yes, we have a specific grade developed for a thermoplastic system. They are available in pellet form, and the specific grade for thermoplastic is matrix 815, if you can take note, or 821. But I strongly suggest to come in contact with us, and then we can discuss with our team, our PD team, which is dedicated to thermoplastic application.
Yes, one more question is, what is the minimal order for the product? Or do you have a minimal order?
We have samples for a lab test, and usually these samples are 50 grams. And this quantity, even if it is low quantity, but the dosage is very, very low. So it is enough to perform a full study at laboratory level.
Yeah, then there was one question regarding an overview, whether we can find on the website an overview of the different TUBALL products for the different polymer systems, like you showed in your presentation.
Oh, yes, all the information you can find in our website, tuball.com. Or, I mean, if you want to have very specific information, you can reach us through the mail.
One question is about very light, whether you can use it also into very light expanded polymers, like, for example, EVA.
This is a specific topic, and like for expanded polymer, yes, we performed some study, we have some cases, but it is better to discuss, let's say, face to face with the specific expert in our team.
Yes, and I think it's also a question which is, for example, in hospitals, whether like anti-static clocks, or is it desired to have anti-static clocks? He principally writes, are banned no anti-static clocks. Else, do you have any background into cast polyurethane reels?
Yes, we have some you have experience. I mean, we have customers that are using our nanotubes into the production of wheels using polyurethane casting material. So yes, we have grades. I mean, basically you could use the matrix 202 or 209 grades, just if you want to take note of the grades that you can use for this specific application.
I think I will wait some more minutes for questions, but I think this is more, we covered more or less all the questions which were asked. I think if there are any other questions, please send your questions to webinar@OCSiAl.com, and we will contact you and give you more information on all the other, on all your specific applications. I think, thank you for joining us today, and then see you next time.
Thank you again, also from my side.
Bye-bye.
Bye-bye.